Now, our next topic would be integration. First thing in integration, we are going to write all the rules of integration as anti-differentiation. For example, if we integrate x power n dx, it is x power n plus 1 over n plus 1 plus c. This is rule we took, the only rule we took in the AS. But now, as I said, we are going to look at integration as anti-differentiation. What is the integration of e power x dx? Is e power x anti-differentiation? Because the differentiation of e power x is e power x, even the integration of e power x is e power x. Also, the integration of 1 over x dx, we say it is ln x. We took this as the differentiation of ln x is 1 over x. Even integration of 1 over x is ln x. But since ln only applicable for positive numbers, we put modulus here. And every time we integrate and the answer is ln, don't forget to add this modulus. These three basic rules, we can add to them the basic ones in trigonometry. Anything we know in trigonometry as differentiation, we reverse it. What is the integration of sine x? Is negative cosine x plus c, because the differentiation of cosine is minus sine. What is the integration of cosine x dx? Is sine x plus c. Differentiation of sine is cosine. What is the integration of sec square x? We know that if tan is differentiated sec square, therefore the integration of sec square is tan x plus c. As I say, we are going to write all the rules of anti-differentiation. What is the integration of cosec square x dx? Negative cotan x plus c. What is the integration of sec x tan x dx? Is sec x plus c. What is the integration of cosec x cotan x dx? Negative cosec x plus c. But all these are rules, we know them because we're doing them as an anti-differentiation problem. Fine. Now we are going to go into new, standard rules. The first new standard rule is this. I take example first and I write the rule. If I said to you, what is the integration of x squared plus 3x to the power 5 times 2x plus 3 dx. You say to me the answer is x squared plus 3x power 6 over 6 plus c. Why? Because if I differentiate this, I get this. The differentiation of this is this. Therefore, the integration of this is that. If I differentiate a, I get b. If I integrate b, I get a. This means we can write this in a rule. Call it a standard rule number 1. The integration of f of x to the power n times f dash x equal f of x power n plus 1 over n plus 1 plus c. And that becomes what we call a standard rule. Every time we integrate a bracket to some power, provided its differentiation is multiplied by it, we increase the power by 1 over the new power. We can have similar rule to this. The integration of e power f of x times f dash x. This would be e power f of x plus c. And the reason is because if we differentiate this, we get this. And we can have the third rule of the same type. What is the integration of f dash x over f of x dx dx dx? Then this is going to be ln f of x modulus plus c. And why again? Because if we differentiate this, we get this. All these rules are true because if we differentiate the right-hand side, we get the left-hand side. Many examples about these 3 rules. And we have plenty of of questions about these 3 rules. For example, if I said to you, what is the integration of, right? Now, x squared bracket x cubed plus 5 to the power 4 dx. You say to me, this is a bracket, and this is its differentiation. But its differentiation is missing 3. We can imagine that there is a 3 here, and there is a 1/3 there, and we can do it simply like this. 1 over 3 outside, then the integration of 3x squared x cubed plus 5 power 4. Okay, dx. And therefore, there will be 1/3 outside, and then we say x cubed plus 5 to the power 5 over 5 plus c. Then we make it as a rule. What is that rule? If the differentiation is missing a number, in the answer we divide over that number. For example, what is the integration of x, the square root of x squared plus 1 dx, which means the integration of x, the x squared plus 1 power half dx. The differentiation of this is 2x. The x is there, but the 2 missing, so we write half in the answer. And we write x squared plus 1 power 3 over 2 over 3 over 2 plus c. This is how we can use these standard, I call them, right, forms, standard forms of integration. What is the integration of sine cube x cosine x dx? We say this is equal to the integration of sine x all cube times cosine x dx. And the answer is sine power 4x over 4 plus c. What is the integration of tan square x sec square x dx? Then it is straight away equal tan cube x over 3 plus c. Because tan is a function and sec square is a differentiation, and therefore we increase the power 1 by the new power. A lot of interesting integrations of this kind. If I say to you integrate of, for example, ln x over x dx, you say it is the integration of ln x times 1 over x dx, which the answer is ln x squared over 2 plus c. All our problems, based on the 3 standard rules. These are, we call them the 3 standard rules. Now, what is the integration of 1 over x plus 5 dx? Now, this is the third special rule say that whenever you have a quotient and the numerator is the differentiation of the denominator, the answer is ln the denominator, x plus 5 modulus plus c, straight away. If this is the differentiation of this, then it is ln this. What is the integration of 1 over 2x plus 3 dx? What is the differentiation of 2x plus 3? It's 2. The 2 is missing. Then we put half in the answer. And we say half ln 2x plus 3 plus c. What is the integration of x over x squared plus 1 dx? Then this is equal. Differentiation of x squared plus 1 is 2x. 2 is missing, يبقى half ln x squared plus 1 modulus plus c. All these are examples about these 3 important rules. These are three very important rules. Now, we go then to trigonometry, and we're not just considering the standard rules, but like we consider trigonometry in general. Trigonometry, we call this the type number 4 of integration, trigonometry. Now, what is the integration of cosine 4x dx? Now, the integration of cosine is sine, but we should have the differentiation of sine 4x would be 4 cosine 4x. But the 4 missing, that's why we put 1 over 4 sine 4x dx. But in general, we can say, for example, the integration of, sine kx dx is negative 1 over k cosine kx plus c. Right. Therefore, in trigonometry, we say in general like this. In differentiation, we multiply by the number in front of x. In integration, we divide over the number in front of x. We make this general rule. What is the integration of sec squared to x dx? You say this is equal half tan 2x plus c. In integration of trigonometry, we learned certain integrations. We learned how to integrate sine, cosine, but we did not learn how to differentiate, how to integrate tan and cotan. Therefore, now we are going to talk about new rules for trigonometry, new ideas for trigonometry. What is the integration of tan x dx? We say it is the integration of sine x over cosine x dx. The sine is a differentiation of the cosine, but there's a minus missing. Therefore, be a minus in the answer, minus ln cosine x plus c. We can leave it like this, or we can take the minus as power. It will be ln sec x plus c. Now, the same thing if we integrate cotan x dx. We call this integration of cosine x over sine x dx. And now this is the differentiation of this. The answer is ln sine x plus c. See, we added rules, new rules for integration And then we know how to integrate sine, we know how to integrate cosine, we know how to integrate tan, we know how to integrate cotan. Actually, the integration of sec and cosec, we don't have to know if their answer is given in the formula sheet. And you don't need to know why I like this. You are given only the rules, how to integrate sec and how to integrate cosec. And then, and the only thing is that you just copy the rule from the formula sheet, and that is all. And then therefore we can say we know how to integrate all the 6 trigonometric functions. Now we come to the squares. We know only how to integrate sec square and cosec square only, but we don't know how to integrate the rest. Now we are going to learn how to integrate, for example, what is the integration of tan square x dx? We convert tan square into sec square x minus 1 dx, because we know that sec square 1 plus tan square, but tan square is sec square minus 1. Integrate sec square is tan x minus x plus c. And the same, we can integrate, right, cotan square x dx. We say it is the integration of cosec square x minus 1 dx, which is negative cotan x minus x plus c. Therefore, now we know how to integrate also tan square and cotan square. One more thing is how to integrate sine square and cosine square. These are very, very important. We have to go back to the rule of cosine 2a, which say cosine 2a equal to 2 cosine square a minus 1, or 1 minus 2 sine square a. From this, we can write cosine square subject. Cosine square will be half 1 plus cosine 2a. And sine square a will be written as half 1 minus cosine 2a. Therefore, if you were asked to integrate cosine square x dx, you write instead the integration of half 1 plus cosine 2x dx, which would be half, open bracket, x plus half sine 2x plus c. And the integration of sine square x dx, the same answer but minus instead of plus. It is the integration of half 1 minus cosine 2x dx, which means half x minus half sine 2x plus c. And this is the difference between them. Therefore, now we know how we integrate all the squares of the 6 trigonometric functions. We know sec square and cosec square, they have a standard anti-differentiation. Tan square and cotan square, we convert them to sec square and right, a cosec square. But sine square and cosine square, we convert it into cosine, double the angle, and then we integrate. And this is the integration for the trigonometry. And don't forget, as I said, when there's a number with the x, in integration we divide, in differentiation we multiply. These so far are in actual fact all the standard rules and the anti-differentiation. We can say we took so far now is 4 things in integration, 4 standard rules and all the type of questions of trigonometry. One more type of question we know how to do is this kind of question. I'm sure when you see the question, you will know how to do it. If I said to you, for example, we wanted to integrate x minus 5 over x plus 1 for x minus 2 dx. Straight away when you look at this form of rational function, you say to me, this one can be done by partial fraction. That's it. This is integration number 5, is partial fractions. We are going to take this first, x minus 5 over x plus 1 for x minus 2, and we do the partial fraction a over x plus 1 plus b over x minus 2. If x minus 5 equal a times x minus 2 plus b times x plus 1. If we substitute x equal to -1, then we get -6 equal. This is 0. X equal -1, -3a. If a equal 2. And then if we put x equal to 2, then we get 2 minus 5, -3 equal. -3 equal. Right, if you put x equal to here, 2 minus 5, -3. 2 here is 0, you got 3b. This means b equal -1. Therefore, our function x minus 5, our rational function over x plus 1 for x minus 2, it is equal to 2 over x plus 1 right now, and -1 over x minus 2. Therefore, the integration of x minus 5 over x plus 1 for x minus 2 is going to be the integration of dx 2 over x plus 1 minus 1 over x minus 2 dx, which is 2 ln x plus 1 minus ln x minus 2 plus c. Or it can be combined into 1 ln x plus 1 square over x minus 2 plus c modulus. Now we come to case number 6. Is something we call integration by substitution. For example, we all know how to integrate x squared plus 5x to the power 4 times 2x plus 5 dx. We know the standard rule for it. The standard rule is x squared plus 5x power 5 over 5 plus c. But sometime in the exam he will ask you this. He will say to you, solve using the substitution u equal x squared plus 5x. Then the solution would be differently. At the end we get the same answer, but the solution is different. Once he say using substitution, then we have to do it by substitution. What is the method of substitution? Is this, that the whole integration will be converted from integration in terms of x into integration in terms of u. U equal x squared, right? We say in our solution u equal x squared plus 5x. We differentiate. We say du by dx is 2x plus 5. Cross multiplication, we get du equal 2x plus 5 dx. The whole integration will be now integration in terms of u. It will be the integration of x squared plus 5x is called u power 4. 2x plus 5 dx, all of it is called du. What is the integration of u power 4 du? U power 5 over 5 plus c. Then substitute what is u. يبقى x squared plus 5x power 5 over 5 plus c. This is the rule of substitution. Another example. We have to integrate, right, e to the power sine x times cosine x dx. But he did not say to me just integrate. He said using the substitution u equal sine x. Then we solve. We don't try the rule straight away, no. We say u equals sine x. What is du by dx? Cosine x. Cross multiplication du equal cosine x dx. The integration of e power sine x cosine x dx would be equal to integration of e power u du, which the answer is e power u plus c, which means e power sine x plus c. Some other type of problems. These problems we could have done them straight away, but he asked us to do them by substitution. Therefore, I have to use for a substitution. But substitution can be useful in problems like this. Integrate, for example, x root x plus 1 dx. And he said using substitution u equal x plus 1. Then we say u equal x plus 1. du by dx is 1, yani du equal dx. Then since u equal x plus 1, that means x equal u minus 1. That integration would be equal to x is u minus 1 root u instead of dx du. Therefore, the integration of u power 3 over 2 minus u power half du. U power 3 over 2 is u power 5 over 2 over 5 over 2 minus u power half is u power 3 over 2 over 3 over 2 plus c. Now return the u to x. You have 2 over 5 x plus 1 power 5 over 2 minus 2 over 3 x plus 1 power 3 over 2 plus c. Finally, we can have question like this. To integrate to integrate x root 2x plus 5. But this time he say dx using substitution u square equal 2x plus 5. U square equal 2x plus 5. Therefore 2u u dash du by dx equal 2. This means u du equal dx. Then we have our integration is 2x plus 5 means u square under the root u by u. But what is x? X is u square minus 5 over 2. This is x. And then the square root of 2x plus 5 is the square root of u squared times u. And then dx. And instead of dx, you have u du. Therefore, it becomes the integration of u power 4 minus 5u squared, and there's a half there, du. And therefore the half as it is outside, u by u power 5 over 5 minus 5u cubed over 3 plus c. And now, how do you get u? U equal 2x plus 5 power half. And u equal 2x plus 5 power half. Now, therefore, this means 1 over 10. Instead of u, we got 2x plus 5 power 5 over 2 minus 5 over 3, 2x plus 5 power 3 over 2 plus c. And this is the answer. Right, there's one thing here. When we are getting half multiplied here, half, this is like this, but this would be 5 over 6. One last type of question is, we ask you to integrate x plus 1 power 3 dx with the limits from 0 to 2. Using u equal x plus 1. We say u equal x plus 1, then du by dx equal 1, du equal dx. But one more thing we're going to do is we're going to get the new limits of u. When x equals 0, u equal 1. And when x equal 2, u equals 3. If our integration is, and instead of x, write u minus 1. And x plus 1, we write u cubed. Instead of dx, we write du. And the limits are from 1 to 3. Therefore, we integrate from 1 to 3, u power 4 minus u cubed du. It is u power 5 over 5 minus u power 4 over 4. With limits is no c because there are limits. Therefore, we get 3 power 5 over 5 minus 3 power 4 over 4 minus 1 over 5 minus 1 over 4. And we calculate this, we get the answer. This will save us, and instead of returning u to x and then putting limits for x, no, we got the new limits for u. And therefore we say integration with limits by substitution, it is an actual fact, it will be better integration. Right. We are going to stop at this point in integration. We do have in actual fact, right, 2 more problems of integration, and then also some other additional things. We explain this in a later lecture. Right.